Hello and welcome to this screencast on muscle fibre types and exercise intensity. Okay, so what I want your core notes to look like is this on the screen. So we are going to be talking about aerobic work, anaerobic work, mitochondria, myoglobin, phosphocreatine, slow oxidative muscle fibres, type 1, fast oxidative glycolytic fibres, known as type 2A, and finally fast glycolytic muscle fibres type 2X. If you pause this and get that down, we'll move on. So in regards to exam questions, this is the type of question you're going to be asked in an exam. So first of all, I've got this one on the left. Tennis match can last over 3 hours. Figure 2 shows a tennis player serving the ball during a match. Explain why 2 different muscle fibre types are recruited when playing tennis. That's worth 4 marks. And then we've got quite a biggie over here, which is worth 10 marks. Spencer is a cyclist. He takes part in a long distance race. He recruits different muscle fibre types to meet the changing demands of the race. Analyse the neuromuscular control of muscle fibre type recruitment during Spencer's cycle race. So hopefully at the end of our lesson we're definitely going to be able to answer this on the left. This one we're going to be able to answer part of it. We're not going to be able to answer neuromuscular control because we haven't done that yet, and we're not going to do it in the lesson. First of all, aerobic work versus anaerobic work. So first of all, when we're talking about aerobic work, we're talking about work done in the presence of oxygen. Okay, so it's low intensity, long duration exercise in the presence of oxygen, i.e. we're using oxygen to help build energy. Sporting examples would be a marathon runner, for example, long distance events, endurance events. Anaerobic work is the opposite. It's high intensity, short duration exercise in the absence of oxygen. So we're not using oxygen to break down fuels into energy. For example, anything that real high intensity, shot put, long jump, javelin, 100 meters. With regards to the key terms we've got down, first one is mitochondria. Okay, so mitochondria is found in the muscle, so specifically in the sarcoplasm, and it's responsible for aerobic energy production. Myoglobin, similar to mitochondria in the sense of it helps with aerobic energy production. Myoglobin is a protein, okay, and it's responsible for transporting oxygen to the mitochondria. So mitochondria is where aerobic energy production takes place. Myoglobin is a protein that transports oxygen to the mitochondria. And then finally we've got phosphocreatine. Now phosphocreatine is a high energy compound, and it's stored in the muscle and it's used as a fuel for high intensity energy production, such as shot put, javelin, 100 meter sprints. So phosphocreatine is a high energy compound which is used for high intensity work. Okay, so if we're going to talk about the muscle fibre types, the reason we had to know those 3 structures we've just spoken about is because they're going to make up some of these muscle fibre types. So first of all, the first one, type 1, slow oxidative. It's in the title of the name, a slow twitch muscle fibre. It is going to be used at low intensity over a long distance of time. So slow oxidative type 1 muscle fibre is rich in mitochondria and myoglobin. Mitochondria is where aerobic energy takes place. Myoglobin transports oxygen to the mitochondria. It's got loads of capillaries, okay, therefore gaseous exchange can take place. Produces a small amount of force over a long period of time, and it is slow to fatigue. A slow twitch muscle fibre takes a long time to fatigue, hence why you can do a marathon, run for a long distance of time. Low force of contraction and a slow speed of contraction. It's a slow twitch muscle fibre type. Used for marathon running, Tour de France. The middle muscle fibre type is a fast oxidative glycolytic, also known as type 2A. Oxidative suggests that it's got some oxygen properties in there. Glycolytic suggests that it's also got some kind of high force in there. So this is a fast twitch muscle fibre. We have 1 slow twitch and we have 2 fast twitch. This is the first fast twitch muscle fibre, type 2A. Okay, so it's fast contracting, so it produces high force, fast speed of contraction, and it is also resistant to fatigue, i.e. it doesn't fatigue easily. Now an example would be 800 meters, for example. So 800 meters is around about 2 to 3 minutes. They're going quick, they are fast. However, it's going for a bit of time, therefore it's a good muscle fiber type for that because the resistance to fatigue is quite good. Finally, we've got fast glycolytic type 2X muscle fiber types. Okay, fast twitch muscle fiber again. This time no oxidative properties, therefore this one is going to tire very quickly. So fast glycolytic type 2X, the type of muscle fiber rich in phosphocreatine, which we saw earlier on is a compound that is used for high intensity exercise. So it's rich in phosphocreatine, which produces a maximal force over a short period of time. So the force of contraction is high, the speed of contraction is fast. However, it fatigues quickly, so it tires really quickly. Example, 100 meter sprint, shot put, javelin, long jump, anything that is really high intensity. So we go from slow oxidative, long endurance events, long duration, low intensity, slow. Then we go to our first fast twitch, fast oxidative glycolytic. It's a fast twitch muscle fiber, so speed of contractions fast, force of contractions medium to high. Fatigue is still kind of, it's resistant to fatigue, so it doesn't fatigue as easily. So we go from long to kind of like middle to 800 to very short, high intensity, short duration, high force, high power, fast speed. So if you get those notes down, I'd appreciate it, and I'll see you in lesson. Thank you. Bye.